So hello guys, I'm Lingraj and today we are going to do the parts in the assembly of a plumber block. So let's start with the body part. We'll select the front view and we'll first do the base of the body part. So there was a little mistake in the length. Okay, and then take the smart dimensions. Okay, the base of this is 168. See, there's a change in the shape, so we should use the symmetric, so we'll get the same length on the both sides. First we should select the axis and then the element that should be symmetric. See, you can see here. So we'll change the length of this is given as 4 and the length of the height is 14. Okay, come back. There's a option called extrude. This also means the protrusion. In other words, first select the object or the plane or the diagram or the sketch which you want to protrude or extrude. I'll select this one, right click. See, this is only on the one side. It is an option called symmetric here. Click here. See, you'll get on the both side. So the width is 36 mm. See, you'll get like this. So on the next step, select the top view. Click on the face here and lock it. From the center of the body, we should take a circle of a radius 43, that is diameter of 86. We got the circle of 86 diameter, and we should close the part. Here you'll get the mark of intersection. See, the X mark indicates the intersection. We should draw the line. And trim the unwanted part. See, you'll get like this. Back to the home, and there is again you should go to extrude. See, now there was no option the first. Now there is a add or the cut. See, if you want to add the material, you want to extend the material, you should take the add option. You want to remove the material of that shape, then you should take the cutout. So we are adding it here. Add. See, the symmetric portion is on. See, I'll show you how it will be. Right click. See, you'll get like this, but we want only in this upper direction. We'll just click here. See, okay, the total length of the body is 55. So we already took the base length as 14, so 55 minus 14 will be 41. You can see here. See, you'll get this one, this much. So next we want the semicircle here on this face, so we'll lock this face. Just we'll draw a circle of diameter 38. See, got the diameter. Just now from the center point there is a tangent or the part here, center point. See, we want the height of this length. We should get it as 3, or at the starting you can take it as just take it how much you ever want. We can change it later. See, you'll get like this. Here, take the fit and just move and trim the part which is not required. Then come back, and again the both the length sides should be symmetric to the axis. So click on the axis, click on the side that should be symmetric. Okay, now take the smart dimensions, change the dimensions. The length of the small part should be for us 3 mm, and the length of this, it should be of 12 mm. The total length, that should be 44. See, we got this. Now trim the non-required part like this. Okay, come back, you can see the sketch here. Now you should remove this part. So again, go to extrude. There is an option called cut. You can choose symmetric or symmetric. Now I am choosing the symmetric. Click on the part you want to remove. See, chosen this part. Right click. See, symmetric. Cut out. See the front view. The isometric wave you can see here. Okay, so now hide the sketches, everything, sketches, all this. Come back. Now we need to remove a rectangle portion that should be back. See, you'll get the back portion. Click on the bottom side. Okay, lock the face. See, they have not given any measurement of the rectangle, so we'll take the rectangle of any length, but they have given the measurements of this. See, they have given every side as 8 mm. The distance between this edge to this edge, side to side, is 8 mm at all the sides. So we'll take it as 8, and this one as again 8. Okay, it's not changing. Okay, now see, we got the rectangle. We want the same rectangle on this side, so there is an option called mirror. Just select it. See, keep the cursor on the axis, so you'll get this rectangle on other side. Okay, come to the extrude. Again, we should remove the material, so click. Select the part you want to extrude, right click, come back. See, it is on the symmetric option is on. Just we'll off it. See, okay, and the depth we should remove the portion is of 2 mm. We'll just mention it, 2 mm. Enter. See, you can see here the 2 mm, the edge has been cut. Now we should make a chamfer. There is a option called round. Go there. The round, blend, and chamfer of equal setbacks. So we need take the chamfer of equal setbacks, click the edges, the upper edges. See, I can see the upper edges here, line of 1 mm. In the chart, they are given the dimensions, chamfer, and radii of description box. So they are given the chamfer of 1 into 45 degree, but it is already in the 45 degrees. So you should mention the length. See, it is already 1. I'll enter it. See the slant edges. You'll get like this. Okay, come back. So again, we should make a square cutout in the inside this. Again, go to the bottom part, click on this surface. Okay, take off any dimension. They have given the dimension of 20 mm square. First, we'll measure the center point and the axis length. The same square should be made on this side also. First, we'll measure this one. We'll take the measurement of go to the smart dimensions for measuring the side. See, it is 13, but the actual size what we want is 20. Okay, we'll change in the ascending or descending order. Okay, first we'll change the distance between the axis length and center of the center of square is 62 by 2, that is 31. Enter, and change of this length, it should be a 20. Enter. Okay, see, this portion, it is in the blue color. Just delete this. Now you can again measure it. It's coming like this. Okay, you should never get that portion in the measurement in the blue color. That means it will be a fixed one. So we're deleting it. Again, we'll do, see, click here, we'll get, see, select this one, 20 and 20 again of 0 degree. Okay, now the midpoint between, select the option called distance between. I have selected already the midpoint of this one. So you'll get a note like this that you have selected the point. Next, click on the axis. See, you'll get the measurement of 36. But the actual length what we want is 31. You'll get like this. Okay. Now again, measure the side length. See, you have you already got the changes in it. 17.21 square. So we'll make a change. We want it as 20. Now there's an option called move. Just select the subject or the sketch we want to move. So I want to move the square. I click down it and you can see the midpoint of the square. I'll click on this. I'll just drag it down. You can see the intersection point. Okay, I'll click here. See, it should be on in this box. It should be in this box only. See, 2020. There is no change in the dimensions. Now we'll mirror this because we want the same square on this side. So we'll take the mirror, select this sketch square, click on the axis. See, if you want, you can measure the change distance between these two. So it's not showing, but see, when you mirror, the same length will be the same distance will be there. So we'll come back. Next, extrude. Again, we should remove the material. So we'll cut out it. So it will take time like this. Click on the side. See, right click on it. Come back home. See, it is already in a symmetric. So we want cut in the upper direction. So at the deep of or the length or the height of the removed part should be 7 mm. 7. Okay. You can see here the 7 is measured here, and the depth you can see here. Okay. Come back. Okay. Now we should draw a circle here. So we'll click this face, zoom it. Okay, see, you can draw anywhere, but instead of that, just measure this midpoint, come down, see this midpoint and this one, it's already here. So I'll draw the, we should make a hole. First I'll draw a circle of diameter 10.5. See, I got the circle. Next, we should measure the distance between the center point and you got it as 30.53, but we should get the distance between the circle and the axis is 31. So delete this one again. Show the dimension. Okay, there is a option called move. Okay, when you select the center point and you want you are moving on the same line or the surface, see, on the same x-axis. See, we want 0.5, 0.47 more. So when you come here, there is a changes in here. See, so I'll just move it and I'll type the x-axis length. What I want to increase is 0.47. 0.47. Enter. And I'm not changing in the direction of y-axis, so I'll direct it is already in a 0 mm, so I'll enter it. Just click the point, come back, and now you can measure the distance between see, you have got 31, and we want the same circle on the other part of this axis, so we'll select the circle. See, I have got one more circle here. Okay, now same thing, extrude. We need to make a hole in it, so I'll take a cutout option, if you want to take it is in a symmetric or non-symmetric, it's your wish. So I am taking the symmetric option here right now. I am clicking the circle. Okay, come back, right click, see, you can see the home. I'll click it here, see the top view. Okay, like this. If you want to see it from the bottom, see, first we made the chamfer of the deep 2 mm, next the square of 7 mm. Next you can see the whole part here. Okay, come back and hide the sketches or okay. Now see, we should make a semicircle oval like shape here. So on this face, so I'm clicking here, you can see the face which I have selected. Come down, zoom how much you want. See, I'll take the center point of the circle as this point, end of this point, and I'll not take this one. I'll select another one. I'll take the circle of circle diameter they have given, radius they have given as a 5 mm, so the diameter will be 10. Okay, on the same axis I'll take, see, you can see the center point, midpoint. I'll take in the same direction. I'll keep the another circle here. Okay, see, you can see the measurement. Take the smart dimensions, you'll get it, both the circles of 10 mm. Now distance between the center of these two by taking the option called distance between. Okay, see, it is 12.38, but the distance between the center of the two circles, it is given as 8 mm. Okay, you'll get like this. Okay, now we want a rectangle portion like this. So as we did earlier, we'll click on this part, and here you can see the length of this is 8 mm. We also we also want the same 8 mm length line of 0 degree. Now come back, click here, 8 mm length you can see, and 180 degree also you can see there. Okay, next trim the unwanted part, the inside part which is not required. Now you can see the shape which we want, and we should they are given the distance between this one, and again we should mirror the same part on the other side. So I'll just measure. See, I'll take the midpoint, this, the length, you can see. I want the distance between these two, the distance between is 128 divided by 2, that will be a 64. See, you got it, the length you can see here 64. Okay, 8 mm, 10 mm. Okay, now make it fit. Okay, next mirror the image on the other side. So we want this image, click on the axis, you'll get the same image here. Now as usual we did extrude it. Okay, we want to remove the part, so I'll click on this, come back, right click. See, if we do it in a symmetric or a non-symmetric, it is left to you. I am taking it as a symmetric. I'll just click it out. Now see, okay, see the bottom part, see, you can see the whole, first 2 mm depth, next square of 7 mm, next hole, and next this part. Okay, come back. Now we need to do another thing that is important. There is a hole in between the body part, so we'll take from here. See, if we take length from here, the whole part will be not cut, so I'll be taking it from here. First take this part, and you can see it here. See, it is in the middle part. Okay, fit it, come back to the front view. Okay, now it is a circular hole. Okay, so it is a circular hole, and the diameter of the circle will be, or the hole will be of 6 diameter, so half of it will be 3. See, you have got inside here, so take a move option, click here, just move upwards, it's better. Okay, now take a line, because you can't measure, we want the measurement from this part to this part, so it's not possible to take like that. So first we'll draw a line, and there is an option called tangent. Just click on the line and the part where you want to connect it. See, okay, now smart dimensions, we want this length. Okay, this length we want it as 6 depth. Okay, now we should measure this angle, because they are not given this any angle, but as usual, see, that cone, you have seen the cone, right? See, the angle of the tip point, the cone will be 118, so half of it, 118 divided by 2, it is 59. We'll take like this. Okay, come back. Okay, let it be. See, there is a revolve, we want it in a circular, so there is a option called revolve. See, again in this, see, it is in a symmetric, we are not using it, we want it in a 360 degree. I'll show how to make it 360. See, again, there's option called, you can add it here or cut it. So we want to remove the portion, we want a hollow portion, so we'll make it hollow by taking it as a cut option. Next, we want it in a hole 360 degree, so click on the part or the object. See, I have clicked it, right click, they see, you'll get the option like this. Again, click on the axis now, at from which axis you want to make it as 360 degree. So I'm selecting this part. Okay, see, you can see now. See, the image, it is formed, you can see the whole part like this. Okay, I'll hide this, all the sketches, which is again live sketches. I'll not show that. Okay, see, in the live sketches, you can see this part. Okay, I'll hide it. See, a hole, you can see here, and again the part. See, the plumber body part of the plumber block is ready. So now I'll save it. So you can save it as PB anything. I'll make it as PB body. Okay, PB body, save. It has been saved, and Next, we'll do the cap part. Okay, sure. So hello guys. So we'll start the second part of the plumber block. First, we'll select the front plane, then click on the circle option. Create a circle at anywhere of one of diameter of 30 and create another circle from the same point, from the same midpoint of radius 36, and there will be a diameter of 72. Come back and you can measure the circles. See, it'll get like this, and we have to create a step over here. And let's remove the not required part. So first main thing, we'll do this. We'll keep the distance between this. We'll take the option called distance between. We'll select the midpoint of the circle and the axis. The total length between these, it should be of 18. See, make it like this. And the first step, it should not exceed, it should be under 3 mm, so we'll keep it as 3. And the length should be of 12 mm. Zoom in, and again the length of this step, it should be of again 10 mm. And another thing is the distance between center of this and the step up line, it should be of 6 as mentioned. So we'll get this. So we'll just and sure that we'll close this area and remove the unrequired part. Now using the mirror image, mirror option, just take the mirror, the object or the sketch. So trim the middle part, or you can say it as the center part. So we got the whole image. Now return to home and click on the part for protrusion, or you can take extrude it. Click on the surface or the sketch you want to extrude, right click, say it is only in the one direction, you want it in the both, so we'll click on the symmetric. See, so the total width is 36. Okay, got it. Again we come back, we'll select the top portion first. We'll do a circle of diameter 86. Join the lines, so you can see the intersection point. do it on the other side. Okay, now trim the unwanted portions. Make sure that you close this area. Okay, come back, return to the home. See, from the front way we can select this. The sketch is what we made here. So again, go to the extrude. So we are adding the material. Just click on add. We want it on the single direction, so we'll not choose the symmetric part. Click on the sketch, come back, right click, see, and the length they are given it as 10 mm. See, same thing we'll do. Now we should make a hole on both the sides. So again we'll choose the top width, draw a circle of diameter 10.5 and the distance between the center of the circle and the axis is given as 31. Again measure this, it is 10.5. So we want the same circle on this side, so we'll by mirroring we'll get it. Okay. Now same extruded, we want a hole, we'll take as a cut option. You can choose a symmetric or non-symmetric, so I'm choosing here, I'll do it on the symmetric side. So return to home, just right click, see, so yeah, you can see the holes. Now the last part is left. Again select the top width, from the center of the circle just take, okay, you should take a arc by center point, which will be available in tangent arc. So arc by center point, we want the radius of 12. We want it on the same side, so again from the midpoint of the circle we'll take the radius of 12. Make sure that you'll join the sketch you want to extrude or remove, cut out, whatever you do, make sure that the sketch should be a closed one. Now so we want to remove the material from this part, so we'll take cut option, and here we want only in the one direction, so we are not taking any symmetric. See, in the front view we can see the sketch what we have drawn here. Okay, select the part which you want to exclude it. Okay, right click, we are excluding or removing the part from that side. Okay, and just click here, see, you'll get the arc like this, and here it comes the what is required for the second one. This is cap of the plumber block, so we'll save it. set as PV tab. So guys, we'll do the third and the fourth part of the plumber block. So first we'll select the top web for the third part. Next we'll take a basic sketch. Okay, with the smart dimensions, take the dimensions. So first thing we'll do is it should be asymmetric. So first we'll click on the axis, and then the elements. Okay. Now the base part, it should be a 50 mm. Then we'll take the total diameter is 25. The half it will be radius will be 12.5. This one, the total diameter is 35. Then the radial become 17.5. The diameter, this part is given as 38, so it will be of radius 19. This part, the total diameter is 50, it will be a 25. So the distance between these two plates, it is 22. Click it again. Okay, and the distance between these two parts will be of 36. Okay, draw a line here and click on the construction. See, we use it for the main axis because here we are using the revolve protrusion or extrusion. So we'll click on the part which you want to protrude. See, okay, here it will ask the axis from which you should select the axis. So I'm selecting this one. Come home, you can see here we want only 180 degrees from the bottom or a third. So we are doing the third part, so we want it at the bottom side. So we'll click here. See. And next, hide the sketches. So you can see here, even in the view, see how it looks. See, as given in the paper. I'll make it again solid. Come back. So again, there is a come back. at the bottom face there will be a tangent. You should create a plane along the tangent, so you can see here. So we want the tangent on this plane, so at which angle you want it. So you want it at the 90 degrees. So now we have created a plane. Come back. Okay, you can see here. Okay, now lock the plane on which you want to draw. So here you want an circle, okay, of diameter 6. So we want to add a part, so we'll add it. The length what we want is just 5 mm, but as we are selecting symmetric, so it will be at 10. Even hide this plane's reference plane. So here you will get here we will finish off this third part. See, so then we'll save this part. BB, it is given bearing bottom half, so we'll make it as BB half. And then next save it. So it is a save. So here it ends the part number 3. So guys, now we'll start the fourth part. It is same as the third part what we have did. So again, go to the top of the basic structure. The smart dimensions, take the measures. And next, the part should be symmetric on the both sides, so we'll click on the symmetric option and click on the axis. See, the whole part is symmetric now. Now I'll change the dimensions as per the requirements. So the baseline it should be a 50, and then that is put on the axis, and the base it should be of height 12.5. Here it should be of 17.5. Next we'll change here, it should be of 19. it should be 25. The distance between the plates, it should be 22. Here 22. Here it should be a 36. So bring the see, you can see the measurements. So again we'll draw a line on the axis. Okay, here will be a construction. Click on it. So again we'll do the revolve port rotation for this one. Here it is asking the axis, from which axis you want to revolve it. So this will be our axis. Come back, see, our fourth part, it should be 180 degree on the upper part, so 180. Okay, so little bit wrong. If it comes downward, it need not be worried, but while doing the assembly again, should make sure that the part comes on the upper part. See, and hide the sketches. In the part they have shown that there is a hole inside here, so it'll come. We'll come to the bottom surface, and again for more planes, click on the more planes, you'll get here the tangent. Click on the surface, see, at angle of 90 degree move on to the surface, click here. Okay, now want to remove the part on it, so click lock the plane. Click on the center, and the diameter is of 4 mm, and the depth, they have not mentioned the depth, so again the depth we are taking it as 5. So click here, so you can see the hole as given in the image. It's the hole is starting from 12.5 to 35, sorry, 17.5, so it will be a 5. Here we are removing, so we'll click on the extrude. We are removing the part, so cut out to be asymmetric portions. Click on the sketch you want to extrude or remove it. So come back, click on the extrude, cut out here, the length on the both side, then it should be of 10 mm. should not be observed. Here extrude again. Should be a symmetric, so we are making 10 mm. Come to home. Give here. So you can see a hole here. Should be there. So what we made was correct. So hide the planes. Okay, and save it. So we'll save it as BB bearing top half. So BT half. Save it. So guys, here we'll do the fifth part. So first we'll select the top plane, and we should draw a square of 18 mm. So first we should extrude or protrude it. Here they are given it as symmetric, but you can take it as symmetric, but I want it only on one side, so I'll not use the option. Come back home. The depth, it should be of 6.5. So you will get here. Again, click on the top web. Okay. For making a bolt, first we'll make a circle of 10 mm diameter. So again, extrude it. So we want to add the material. Come back. So it is only on the one side. If we take it on, it should not be asymmetric. We want it only on the one side. So the total length this bolt, it should be of 75 mm. You can see here. Okay, again for the bolt there will be a threading, so there is option called thread here. See, based on the threading, there will be many types of threading. So they are given it as M10. So we'll select the M10, and here we should do only a 26 mm threading from the starting of this position. So it should be a finite. Okay, click the portion of where you want to do a threading. See, it is given the 15 mm, but we want it as 26. See, you will get like this. And the next thing, you should make a chamfer. So we'll go to round, and there will be an option called chamfer of equal setbacks. Here, chamfering, we'll take it as 0.5 mm. See, you'll get the chamfering like this. Better. Now, return to the home. Okay. We should again chamfer the square part of square part, so we can do it directly. So just make a lock of this right web. Okay. Take a line, just make of create a triangle or any shape. After that, the angle between the line and the surface, it should be of 60. Now come back, you can see here. So again, we should cut out this area, so we'll take a revolve protrusion or a revolve cutout. See, don't put on a symmetric. We'll click the sketch you want to revolve here. The axis is a central one here. We'll get, but we want it on a full 360 degrees, so here there will be an option called 360. Just click here. See, you'll get the chamfering. Okay, come back and hide the sketches, save it as so I'm saving it as a PB bold. Save. So next we'll take up a new page. Okay, here we want only the reference planes. Okay, now select the front plane. We want a hexagonal headed nut. So there will be option in the square or rectangle by a center. You can see a option. There will be a last option called polygon by center. Click there from the center part. See, you'll get the hexagon. And distance from the center of hexagon. We want it as 10, and it should be a 0 degree. Okay, now click on the extrude it. So click on the part, return. See, you'll get on the only in one direction, so I want it on both. Go to symmetric option. You want the bolt, the nut of 8 mm thickness. See, now you should do the chamfering. First, I'll take a line for access purpose. So I'll using construction option. I'll make use of it, and again on any part of the side, just as we did earlier for the part 5 for a bolt. Again, click on the surface, make any shape, and the angle between the side and the surface and the side, it should be of 60 degree. Okay, we want it on the both sides, so using the mirror option, just mirror it back. So for the chamfering, we'll take a double cutout. Okay, we want the whole 360 degree, so I'm selecting at the first 360, and I'll select the sketches to make. Okay, come back, return. Here it is asking for the, see, you can see here, click on the linear edge to be used as the axis. So I'll click on this. See, you'll get the chamfering portions like this. Okay, on the both side. And now hide the sketches, fit it, and we should make a thread in this. So we'll make a circle, of diameter 10. Again, extrude, we'll take a cutout option, so you can use symmetric or non-symmetric for this. So I'm using symmetric option. Click here. Next, there will be a thread option under a hole thread. See, it has already been set of M10 thread. So here we want the thickness of it, but instead of that, there will be another option called to the cylinder extent. Click on that. See, you click on this to the cylinder extent. Next, select the hole. Okay, sorry, 8 mm. See, just click enter. So you'll get the threadings like this, as you can see here. So first we'll save it as baby nut. Save. So another part, seventh part. So we'll take a new part, reference screen. Again, go for the front view. From the rectangle by center, there will be option polygon by center. Again, click on the center point. We need the polygon of 6 sides, distance 10 from the center, and of 0 degree. So again, here we should exclude it. Click on the surface, right click, come back. So it is already in the symmetric. So if we want the thickness, it should be of 5. Okay. Come to the top view. Again, first I'll create the axis for your protrusion, and then as we did before for the nut, same thing we'll do it here. The distance between the surface and the side of the angle, not the distance, the angle, it should be of 60 degree, as you can see here. But we want less than this. We should not access this plane, so we'll do it again. So angle, -60 degree. So we want on this side. So using mirror option, we got it here. So using revolve protrusion, revolve cutout, I am taking it as 360, and then I'll select the sketches. You can see here, right click, then select the axis to revolve. See, you'll get the chamfer. Again, we should make a hole, and it should be a threaded one. So I'll first draw a circle at the center of again 10 mm. So again, using cutout, so it is on the symmetric, already it is in the symmetric, so just click it. See, I got a hole now using a thread option. It has already been set of M10. So I'll just click on the circle. It is showing of 15 mm, so the thickness is 5. Just enter it, so you can see the threaded part. So I'll just save it. Here it is giving us lock nut, LOCK nut. Okay, we'll save it. Then we'll open the new part, the last part of the plumber block. Just select the front plane. You want the circle of diameter 25. Okay, just extrude, click on the extrude, click on the part, right click. There is no limitation of taking the length, so I'll take this as 60. And measure length. See, there's already 25 diameter and 60 length. So this is the last part of plumber block. So I'll save it. PV shaft. So guys, we'll start the assembly of the plumber block. Here you can see. First, we'll take the body part. We'll select it. You can see here. Okay. Just drag the body part. Now, we'll assemble the third part, which is bearing bottom half. That part 3. You can rotate here itself. Related. So now we can rotate here and then drag. See. Now we'll assemble it. Here you can see the option called axial align. In this, we'll assemble this axis. This one. Now you can use again axial align for this part. See. Now we can see through right wave, top wave, in front wave, isometric, and even can wave it by the diagrammatic. See, the part is fixed in this hole. Come back. So now we'll assemble the fourth part, that is bearing top half. So we'll rotate it here itself, then drag the part. There's an option called planar align. Click there. Click on the planar, this plane. There is option called flip. There's another option, mate. And even you can use this axial align. You can see it from the right side. Now we'll use the drag component option. To move this component, click on the y-axis and just drag it and place on the bottom half. Now you can see here, you can see even the top section. You can see from the right. For that you can press Ctrl R. For front view, Ctrl F, and for isometric, Ctrl I. Now on top of that, we'll place the cap, the second part of the plumber block. We'll just rotate here for our convenience. So with the help of again planar align, we'll place it here. Can just flip it. Again there is option called mate. Even you can use this next axial align. Rotated. So just will rotate okay guys, we have a little mistake in this, so I'll just open the cap part in the solid edge. Okay, that another part is remaining for this, that is counter bore. Come to the top part. Next there's a hole, so we'll click on this hole. There is a called hole options. You can click there. See, it is a simple hole, threaded, counter bore, countersink, and taper. So we need counter bore, so we'll click there. You'll get the diagram. Okay, and adjust the dimensions. The diameter of the upper part, it should be of 6, and the length should be 10. The bottom part of diameter 3. So we'll click here and see. can see the contour board. Can view here. See, I have drawn the contour board part. So now we'll save this, and we'll again return to the assembly. See, after changing that, directly we'll get the part here. So now we'll assemble through axial align. There will be more options, you can use those. Or there is another option in drag component, so we can use that. Or you can do another thing, there is just drag another. Okay, we'll first we'll remove this one. Okay, now we'll start again axial align. So we'll just move the part in the upward directions. See, just move this part, fit, or see, it is a free form move. So I'll select this one. You can move however you want, but the axial I have took the first, it will be a kept constant. We'll just come here. Okay, the plane is in the straight, so we'll come to the front fifth. So we'll take this option. You can see the part attaching here. Now you can see from the left side, that is Control L. See, from the top of Control T. We'll just little bit, Control R. You can be visible. See, come back. So now we should assign the bolt. Here it is, bolt. So just drag the bolt here. Here we should use two bolts, one on this side and another on this. So here we can use the axial align. see him. Okay, so it will be direct fit. Okay, just we'll move this part upwards using the drag component, Z axis. Okay, we'll select it here, and we'll move this part little bit downwards, and we'll come back to the bottom part. See, we'll select the freeform move. So the square, it should be fit in the box what we have made the length of 7 mm. Okay, now okay, we'll see the front view. See, even up to the view, and I can see the visible edges. See, the part of the box should touch. There's a little bit gap. Okay, it's okay for that. So we'll come back again. Now we'll assign the nut. Okay, we'll take this. We'll rotate here itself, so it will be convenient for us. Okay, now we'll as we did here, we'll again use the axial align. And take axial align. Oh, okay, you can see here this part is here, so we'll just use the drag component. There's an option called move. This symbol indicates in the straight directions. See, okay, hit it, and can we make an isometric section now? So next, the last step is, sorry, we'll put the lock nut in. We'll rotate here itself for our convenience. Come back here again. We'll use the axial alignment. So again, it is written in the back. So again, we'll just take the visual and hidden edges, and come back. We'll use the drag component, move upwards. First, we'll select this part. It should be seated on the nut. Okay. Same thing we'll do it for this one. Okay. Come to the isometric, Control I. You can see now the last part is shaft. So we'll rotate like this, so it will be easy. Here we'll directly use the axial align and just it will be aligned. Just use the drag component. It is already in the move in the straight direction, so take F Y direction. See, make sure that the shaft should be equally distributed. See, okay. Here it ends the uh, sha plum, assembly of a plumber block. So to convert this 3D image into 2D, we'll just right click here. We'll get an option called create drawing. Click on it. Here you'll get isometric draft. Yes, okay. Okay, first we should save this. Sorry. So we'll write it as assembly of plumber block PB. Save. So now we'll do this again. Create drawing. Okay. You can place it here. We'll set up the sheet. Okay. Sheet setup. You want the sheet setup of A4 sheet. We don't want any background, so we'll click OK. Yeah. Just will fit it again. There is an option called view orientation. So I want only the top wave. So here you can see it is the scale of 2:1. So need only 1:1. We'll get here. Now I'll use the cutting plane. So we'll use the cutting plane. You can see the plane we should cross the central axis. Then here you can see close the cutting plane. Here you get an option. So we'll click upwards of this axis. Now there is option another called section view. Click on the section A to A. So you'll get the section front view and top view of the plumber block.